Okay, in the last section, section 3.2, we looked at the definition of the derivative as a function. We went through those long, drawn-out steps of doing that special limit. The limit is h goes to 0 of the quantity f of x plus h minus f of x all over h. Doing all that gave us the derivative. That was the definition of the derivative. And I told you at the time that there would be shortcuts. And there's some of you that have had calculus before. You kept telling yourself, oh, there's so much an easier way. There's an easier way. Can't we use the easier way? Now we're starting to get to the easier way. But I do want to remind you that there will be a test question, a quiz question, and maybe a question on the final where it says, using the definition of the derivative, find the derivative. And if you do anything else, you'll get it wrong. But other than that, yes, in section 3.1.3.2, use the definition of the derivative. And when I tell you in the future, use the definition of the derivative, use the definition. But all other times, like section 3.3, 3.4, and from now on, you do the derivative in the most efficient manner you can. And so we're going to start getting these basic differentiation rules. Now, just a little bit of algebra review, because it turns out when we get these basic rules, exponents are our friends. So we need to remember our rules about exponents. First of all, the relationship, let's zoom in a little bit here. That's a little better. The relationship between radicals and exponents. That the nth root of x to the m or the nth root of x to the m written that way is the same thing as x to the m over n. That the index is the denominator, the power is the numerator. Negative exponents cause the factor to move. So x to the negative n is 1 over, and there's a typo, a big old typo there. And like I said before, when we find typos, perhaps by the time you actually download these notes, those typos might be fixed. But for now, the typo's not fixed, and I'm not going to go back and redo the lecture. So in the lecture, there's a typo. Maybe when you actually download the notes, the typo will be fixed. But x to the negative n is the same thing as 1 over x to the n, and vice versa. X, and if basically a negative exponent just causes that factor to move. Then some basic rules here. X to the a times x to the b is x to the a plus b. When you're multiplying, you add the exponents. X to the a over x to the b is x to the a minus b. When you're dividing, you subtract the exponents. And x to the a, the quantity x to the a to the b is x to the ab. An exponential expression raised to an exponent, you multiply the exponents. So just a little basic recall there on rules of exponents. Then a little more algebra practice here. Rewrite the following radicals as exponential expressions. Rewrite the following fractions as non-fractions using negative exponents where necessary. And so all we're doing here is looking to rewrite this. And so a big amount of recall here. Remember, a square root is understood to have an index of 2. And very, very, very explicitly, that's understood to be the square root of x to the first or x to the 1/2. Now, no one's expecting you to do this step right here. Let's see if I can rewrite that so it looks a little bit neater. Handwriting really off today. Not going well for this first video for today. But the square root of x is the same thing as the square root of index 2 x to the first or x to the 1/2. You just want to remember a square root is the same thing as x to the 1/2. It's going to turn out that fractions can be difficult when dealing with derivatives, but exponents are going to be our friends. So anytime I can rewrite a fraction with a negative exponent to get rid of the fraction, I'm going to do that. So 1 over x to the 4 is x to the negative 4. We'll do 2 steps here. That's 2 over x to the 3/4. The index is the denominator. The power is the numerator. And so it's 2x to the negative 3/4. Then my point here on this one, and my instructions are a little less, or not quite my instructions aren't quite what they should be. What I meant was rewrite as non-fractions using negative exponents as necessary. What I really should have said is rewrite so there are no variables in the denominator. Well, if I don't want a variable in the denominator, all I need to do here is say that that's 3/5 x to the minus 1/2. That my point on this one is that that exponent of 1/2 applies only to the x. An exponent applies to the one factor to which it's adjacent. And so that 1/2 is adjacent to the x, so it only applies to the x. So when I go to move that x out of the denominator, just the x moves by changing that exponent to a negative 1/2. It's going to turn out fractional coefficients, those aren't going to be a problem. So I'm going to leave the 3/5 alone, and for whatever calculus we're going to do eventually on it, the 3/5 is not going to be a difficulty. Here we have some exponentials. Same rules still apply, even for variable exponents. Remember, e is a number. And so I have e raised to the 2x, e raised to the x. So my base here is a number where my variables, my exponents are variables. Well, the same rules apply. And so that's going to be e to the 2x minus x for e to the x. And then lastly, rewrite that so it's not a fraction. There are a couple of ways to do this, but I think the easiest way to do that is to remember this, that when there's one term in the denominator, and that's what we got here, and multiple terms in the numerator, try, quote unquote, splitting up. And I think that's going to be the easiest way that we'll eventually, when we have to do calculus on this, the way we're going to simplify first is to try what I just suggested here. And so it's x to the 4th over x minus 2x over x plus 3 over x, which would be x cubed minus 2 plus 3x and negative 1. It's going to turn out when we start doing calculus on this, a little bit difficult, not outrageously difficult, a little bit difficult, but calculus on this, pathetically easy. And so the whole point to this algebra review is getting things in simplified form to make the calculus easier. That whenever we can use algebra before we start the calculus, use algebra to simplify the original problem, that's going to help us do calculus, especially on this sort of problem here. Okay, so let's get to some basic rules.